Okay, so today I will show you how to create a custom gear indicator with SimHub so you can use it with your favorite racing game. And as you can see, as I try to play the game in the background, the current gear is being displayed on the display inside this shifter knob. If you want to follow along, you will need Arduino Uno or some Arduino board. Then I'm using this Pimoroni 11x7 LED matrix display. Of course, I need some wires to connect the display to the Arduino. And the most important thing, I need to install the SimHub application, so let's start with that. Actually, before I do that, let me talk about the sponsor of today's video, which is PCBWay. They offer a lot of different services for electronic projects, including PCB assembly, SMD stencils and all kinds of PCBs, but also services like CNC machining, 3D printing and injection molding. I have used those services before and I hope to use them more in the future, so thank you PCBWay, and let's get back to our video. And again, let's start by installing the SimHub application. And that should be as simple as going to the SimHub page and clicking the download button, and of course downloading the zip file, unzipping that file, running the executable, and then clicking the next button for the next few minutes. I'm installing everything that's possible to install, although I'm not quite sure if I really need to install everything, but just in case. And so while this is running, let me tell you a few things. First of all, this is part 5 of the series of creating a custom gear indicator, which means that I already have 4 videos about this topic. In the first video, I was getting the current gear based on the shifter lever position using the Hall sensors and displaying it on the OLED display. Using Hall sensors will not be needed today because the SimHub will actually tell us the current gear. That's the main reason for installing and having this application. In the second video, I was experimenting with this Pimoroni 11x7 LED matrix display. That's the same display that I will be using today because I quite like it. It's very bright and it also allows to show grayscale pixels, 77 of those to be exact. In the first video, I did put this display inside a custom 3D printed shifter knob. And the video number 4 was about a different display from the same brand from Pimoroni, but having 5x5 RGB LEDs. So here we are on the video number 5, but this time I don't want to show the gear from the real car, but rather from the racing game, from some simulation game, using all the knowledge from my previous videos. And it looks like that the SimHub is already installed, so let's launch it. I guess I will keep the default settings, at least for now. And let's see what we can do here. Since I want to use Arduino, it kind of makes sense to click on the Arduino tab. And here I will click on my hardware and select single Arduino because I will be just using one Arduino for now. Then I will click on the Open Arduino Setup tool. And when you click it for the very first time, it will download all the needed files and install those. Although as you can see it was failing, so I had to click the retry button and try it one more time. Actually on my other PC I had to restart it first, but here it seems to be working. And once everything is downloaded, it will open this sketch setup window. And this is where all the magic happens. Now for the first thing I want to select the correct Arduino board. I'm using the Arduino Uno, so I will select Arduino Uno from this drop down menu. And I also want to select the correct serial port, and as you can see the COM number 14 has the Arduino Uno name next to it, which means that this will be the right port. Now sometimes you will see this name, but other times there will be nothing, and if that's the case you have to just disconnect the Arduino, see what ports are in there and then connect it again, and the port number which wasn't there previously is most likely the port where the Arduino is connected. So again, in my case that's the communication port number 14, and then if I look at the left side of the window I can connect a lot of different devices. I can connect the gamepad, all kinds of 7-segmented displays, some LED matrix displays, also the real gauges, and so on and so on. Now our Pimoroni 7x11 LED matrix display is not there, but that's kind of expected. So as a first step I'll try to connect something similar, and it might be tempting to use this 8x8 LED matrix display because after all our Pimoroni display is also LED matrix display. But I will actually use something very different. On the bottom of the list you can see this 74HC 5x5 gear display, so that's the chip being used. And it might not be obvious just from seeing this chip, but this chip is being used to drive the 7-segment displays. And as the name suggests, it will show the current gear on this 7-segment display. Luckily I do have this chip also together with the 7-segment display in the form of the module, which means that it's already soldered and have all the necessary components, meaning all the resistors. Those strange looking components are 4 resistors next to each other, and you need 2 of those, meaning 8 different resistors for 7-segment display. And also as you can see there is not just one chip but 2 chips for 2 7-segment displays. That's probably the only downside of this module. I need only one 7-segment display to show the current gear, but I have 2 of those, which means that the second one will be most likely just, sitting there showing nothing. In fact, you can get this module with 2 displays, 3 displays or 4 displays, but I haven't found a version with just 1 display. So let's jump back to SimHub and set how this module will be connected together with the Arduino Uno. I will click this checkbox to enable this chip, this module, and by default it says those pins to be pins 2, 3 and 4. Now I think that in this case you can use any digital pins. I will just keep those 2 defaults. You cannot use pin number 0 and 1 because those are also used for the serial communication, but any pin from 2 up to 13 should be fine. So you can see that the clock pin is being connected to pin number 4, the latch pin is being connected to pin number 3, and the data pin is connected to pin number 2. And when I started playing with Arduino, I was oftentimes confused with those pin names. I mean, we have data, latch and clock inside SimHub, but we have slightly different names on this module. If I take a closer look, we have pins SDI and SCLK and load. And I think that SCLK sounds like a clock. It's just the S which means serial, so it's serial clock. Then we have the SDI and the S also means serial, so it will be serial data in, so it will be the data pin. By the way, there is also SDO pin on the other side of the board, and that's for the serial data out. I will talk about it later in the video. And finally we have the load pin, and because the only pin remaining in SimHub is the latch pin, let's just say that the latch equals load. So I'll connect those pins in the same way as inside the SimHub, and for that I'm using this breadboard Arduino shield, which makes those connections much easier, and then I will also connect the VCC to 5 volts and ground to ground. So in the end the connection might look something like this. Which means that now it's time to go back to SimHub. And with the Arduino still connected, I will click this checkbox. By the way, this red text makes it feel like you can break something very badly. That's actually not the case. I don't think that you can break something very badly. But anyway, check this checkbox and then click the Upload to Arduino button. And that will compile the code, and after it's compiled, it will upload it to the Arduino. And as you can see down here and also up here, it was successfully uploaded, so I'll click the OK button, and now it's time to play the game, so I'll just close this dialog. Let's go to the dashboard, and I've pretty much downloaded the first game which I found that is free, and that was this Volvo the game, and now I can start the game and play it. Although the word play is questionable in here because I don't need to play it, I just need to run it and test it. So I will just quickly go over all the screens and keep the default settings, and then go straight to the race. And the nice thing is that I can see the current gear being displayed on the right bottom of the screen. And let me actually show both the game and the Arduino at the same time. Now the display already shows something, but it kind of looks wrong, but see what happens when I change the gear from neutral to the first gear. And that will happen right now. As the gear has changed, also the content of the display has changed. And now it changed to the second gear, and the display also changed and updated. So the good news is that something is working, we are just not seeing the correct digits. Now before I try to fix it, let me play the game one more time, but this time inside SimHub I will record my playing. This way I can record all the data and replay it later. Inside SimHub I will click the record button, click the start recording and then start the game and play as usual. Again, I don't really need to play the game, I just need to use as many gears as possible. And since I'm crashing a lot, I'm also using reverse and the neutral, which is great. Here is a section without any turns, and I was able to get from first all the way to the 5th gear. And that's pretty much all I need, so let's jump back to the SimHub. And here I can click the replay button, and it will show me all the saved replays. The one on top is the one that I've just recorded, so I'll just open it and play it, or maybe just grab the position slider and move it around. And as I do so, you will see that again the content of the display changes. I can also increase the speed multiplier, and then the display will change much faster because the playback is now much faster. So let's see what we can do to fix those digits. So here is what's happening behind the scenes. Let's say you play the game, you play the Volvo the game, and as you have the SimHub running, it will somehow use some kind of magic to find out, to look for the current gear inside the game. So it will look what's the current gear inside the Volvo the game, and as it identifies the current gear, it will send this information over the serial port using the USB to the Arduino. So here is the Arduino hidden behind the shield. So the Arduino will receive this data, and there is some sketch running on the Arduino that will say that if the data equals the current gear data, in that case it will update the display with some digit. So if we want to fix what the display is showing, we need to fix the sketch that's running on the Arduino. And we've already set up the sketch using this visual tool, but if we want to show the actual code, we need to go to File, Open in Arduino IDE. And that will open this huge sketch, which might be a little bit scary because there is a lot of code in here and a lot of header files, but that's kind of expected because the sketch needs to support a lot of different modules. In the end, most of the code will be commented out and not really used or compiled, You can see that in our case, we are only using this 74HC595 chip. So what I will do is I will just select the name of this chip and then search for it. So search for this name. And in here I can see some sections. So the display is being enabled. There is some invert variable. We will talk about it in a minute. Then we define all those pins, which we have already defined using the visual tool. And then we have a lot of ones and zeros for setting the content of the 7-segment display. 1 means that the segment will be shining and 0 means that the segment will not be shining. If I keep searching for the chip name, it will jump to the other section of the code, and there is a function called sendData and also a second function called setCharacter or setChar. And I believe that once Arduino gets the data from SimHub, it will look if this is a current gear data, and if that's the case, it will call the setChar function with the character C being the current gear. So you can see if the C equals empty, we don't want to show anything. If it equals R, it will be the reverse digit. If it's N, it will be neutral digit. And if it's anything else, it will be the current gear going from 0 all the way to 9. So it sets the data variable, which holds the ones and zeros for those individual segments to be lit or not lit. And then it calls the sendData function, which sends this data to the actual display using the digital write and shift out functions, which is of course this part. But before we look at those functions, let's briefly talk about how this chip actually works. So here we have our chip, the 74HC595, and this is what's called the shift register chip with 8 output pins. So 1, 2, 3, 4, 5, 6, 7, 8 output pins, and let's name those A, B, C, D, E, F, G, and H. Now, if I set one of those pins to 0, which is logical low, which is also the same as ground, if I then connect the pin to the 7-segment display, so this is the 7-segment display, and if I connect the pin to some of those segments, this segment will not be shining. On the other hand, if I set one of those other pins to be 1, which is also the same as the logical high state, which is also the same as 5 volts, and then if I connect this pin to the other segment, for example this decimal point, now this segment should be shining. And you can see one problem right away because we don't even know how those pins are connected to those individual segments, but thankfully there is some common way how those displays are usually connected, and that's like this. So on the very top this is segment A, going clockwise it's segment B, C, D, E, F and the G in the middle, and the last one is usually not H but DP, which stands for decimal point. Now we need to set those pins to zeros or ones using the Arduino. And I believe that we have the data pin connected to pin number 2, so we will send this data, those zeros and ones. And let's for example say that we send the data 0, 1, 1, 0, 0, 0, 0, 0. So something like this. Now there are two ways how to read or how to actually send the data. We can start from the left side and go to the right side, so it will be 0, 1, 1, 0, 0, 0 and so on. And if we do it like this, you can see that the segment B will be lit, so B, and the C will be lit, and that will form a digit number 1. But there is also a second way how to send the data. We can start from the right side and go to the left side, and in that case it will be 0, 0, 0, 0, one more 0, 1, 1 and 0. So in this case the segment F will be lit and segment G will be lit. And although it looks strange and wrong, it kind of resembles what we were seeing on our display. Here I have the screenshot from the game and it should be showing the first gear, and you can see that on the display those two segments are not shining, whereas in our case those two same segments are shining, which means that not only we should change the order in which the data is being sent, but it should also be in inverse. And if you remember, not so long time ago we were looking at the code and there was this variable called invert, and I think that we want to set it to 1 to invert the digits, but we also want to change the order in which the data is being sent, and for that the shift out function is being used. And if I open the documentation for this function, funnily enough the sample code is for the very same chip that we are using, and on the top you can see that the bit order sets in which order we want to send the data, either from the left side or from the right side, or technically speaking it's the most significant bit first or the least significant bit first, so MSB first or LSB first. Inside our sketch we set this to MSB first, but we want to change it to LSB first. So LSB first from this sample code. I will paste it into our sketch. But there is still one last thing that we need to change, and that's because we have two of those 7-segment displays, not just one. And the way those two 7-segment displays works, or those two chip works, is if you send just 8 bits of data, it will be set to the first chip. but if you instead send 16 bits of data, it will pass the first 8 bits to the second chip. So instead of just calling this shift out function once, I will actually call it for a second time, but this time I will not send the data, but instead just sending all ones, so 1, 2, 3, 4, 5, 6, 7, 8 ones, and this should hopefully turn off the second display. So I'll just save the sketch, and I believe that I can go back to the SimHub and click this checkbox and upload this to Arduino, or I can do the same thing from Arduino IDE, just go to Tools and select the board to be the Arduino Uno and port to be the correct port, and then click this upload button. And this should hopefully do the very same thing as clicking the button inside SimHub. So now we have a new sketch uploaded to the Arduino, and right away I can see that nothing is shining on those displays, so let's try this new sketch with our replay. If I open the SimHub, you can see that the Arduino on the communication port number 14 is already automatically connected, so I will click the replay button and open the last replay, which is the one on top. And at first I thought that something is still wrong, but that's actually not the case. The symbol that you see on the 7-segment display is like the letter N for the neutral. You also see that it's blinking, and there's like the indication that you should change the gear. And that will happen right now, so it will jump to the first gear. And let me actually go through the timeline to see the R gears as well. The other strange looking symbol that you can see is the R for reverse. So it seems like that everything is working perfectly fine, so I think that it's time to move to the next display, the Spimoroni 11x7 display. And judging by the time that we've spent with this simple 7-segment display, you might be thinking that it will take forever, but that's actually not the case. It will be quite simple. Also because I will try to simplify it as much as possible, and also because I have 2 sketches which use this display from my last 2 videos. Now this is the first video, and for that one I have the Arduino sketch running inside Wokwi. If I scroll down, there's a link to the Wokwi sketch, and the Wokwi is a free online Arduino emulator. I can just run it and see the result immediately inside the browser. And as you can see, it's animating this digit number 3 with some kind of animation. Now in order to make our sketch as simple as possible, we will not show any animations, at least not today. If I look at the sketch itself, it's a little bit more complicated than it needs to be because I'm simulating this Spimoroni display using NeoPixels, but let's ignore those NeoPixels for now and only focus on the Spimoroni display, and for that we will need this library, this IS31FL3731, which is the chip being used on this display. Then we need to initialize the display, calling this function, and start the communication inside the setup function. So inside the setup there will be this function ledmatrix.begin. And then we will transfer some image, which is defined as the array with 77 values, 77 byte values. And that's slightly more complicated because the used library is initially done for a different display. So this has to be done in 2 steps, which are down here. And that's pretty much all we need from this sketch. There is also a second video, which is this one, and that's about using this display in the real shifter handle. And again, same as the last time, I have a Wokwi sketch for this project, so I will open the Wokwi sketch and run it. And here you can see if I change the value of those potentiometers, I'm changing to different numbers. That said, from this sketch, we will only use those number images. So if I scroll down, there are those arrays for those individual images. So this is the reverse, neutral, and then 5, 4, 3, 2, and 1 for first up to 5th gear. And I also have this H pattern image. So I will use all of those together with this helper array, which references all those images. So let's actually do that. Let's go to SimHub, open the Arduino, click on my hardware, and click the Open Arduino Setup tool. And since we've already made some changes, it will ask us if we want to continue with our previous sketch, which is the case. I want to reload my last settings and then go to File, Open in Arduino IDE to open the sketch in the Arduino IDE. Let me make this window slightly smaller so I can just copy bits and pieces from our Wokwi sketches. As a first step, we need to include those libraries, but if I scroll down in the Arduino sketch, we are already including the Adafruit GFX library as well as the wire library. So the only one that's not being included is this IS31FL3731 library, so I'll just include that library as well. And if you haven't used the library previously, you have to go to Sketch, Include Library, Manage Libraries, then search for this library name, so IS31FL3731, select the library and click the Install button, and that will install the library. Then close this dialog, and then we need to initialize the display, so copy this line into the main sketch, like so. And then we also need to start the communication with the display by calling the ledmatrix.begin function. And I guess we will do this when we initialize this 74HC595 display, so let's just search for this one to find some initialization. and there is a function called 74HC595 initialization, so init function, and inside this init function, I will copy and paste the LED matrix.begin function, so copy and paste it in here, and then we want to draw stuff on the display, so using those two steps to draw stuff on the display, and I will copy this into the function which is called send data, so send data. I will also send the data for the Pimoroni 11x7 display. But I don't have any images that I can send, at least for now, so I'll jump to the next walkthrough sketch, which is this one, and copy this helper array together with all those other arrays which are for individual images. So up here I will copy everything and paste it into our main sketch, maybe somewhere up here, so it doesn't matter where it's pasted. And as you can see inside our array, we have images for the reverse. I had the image for the neutral, which was up here. I believe it was this one, showing like the letter N. But instead, I've actually used this H pattern map, but I will go back to using this N symbol. And then I have images for first gear up to fifth gear. But what I will do is I will add one more image that will be just an empty image. Let's just call this gear empty map and copy and paste one of those arrays. Use the same name, so gear empty map, and just fill those with empty pixels. That will be 0x00 for all those lines. So I need 1, 2, 3, 4, 5, 6, 7, and I need 11 lines. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. I will delete those values and of course use the Shift tab to change the formatting like so. And then we can draw the images from this gear images array based on the current gear. So I'll just copy this so I can know what are the individual images and jump back to the send data function, which is up here. I'll just paste it for reference so I can know what are the individual images. 0 will be empty, 1 will be reverse, 2 will be neutral, 3 will be first gear, 4 will be second gear, 5 will be third gear, 6 will be fourth gear, and finally 7 will be fifth gear. I will create one more variable and let's just call it gear image Pimoroni 11x7 pixels, and I will set this value inside this set character function. Let me delete a few of those lines so I can see both this array and our functions. So inside this set character function, if the C is empty, I want to set the gear image Pimoroni 11x7 image to be 0, so it's empty. If it's reverse, I will set it to 1, as you can see in here, so it will be 1. If it's neutral, it will be 2, so neutral is number 2, and otherwise it will be this value plus 3. Now this value can go all the way up to 9, and we only have 5 gears, so at some point if you switch to a 6th gear, if that's possible in this game, we will see some garbage, but let's keep it this way for now and we can fix it later. What we need to do is we need to draw the image from this gear images array, so I'll copy the array name inside the draw pixel function and paste it like this for both the first step and the second step. And the index of this array will be of course the gear image Pimoroni 11x7, so that will be the index of the image for both the first and second step, and I think that that's actually all that we need. However, when I click the upload button, it shows me that I'm missing the Adafruit I2C device header file, and a quick Google search shows me that I'm missing a library, so again I will go to Sketch, include library, manage libraries, and the library that I'm missing is called bus.io, again from Adafruit, so I'll install this library as well. Close the dialog, then click the upload button one more time, and hopefully it will compile and upload just fine. But if you see this error saying can't open device, the access is denied, it's most likely because the SimHub is still running and still being connected to the Arduino. And since only one application can be connected to the Arduino, you need to close the SimHub and then upload the sketch. And it looks like that it finally worked, so let's just connect the display to the Arduino. The display uses I2C connection, which means that it will connect in the very same way as any other I2C device. The ground goes to ground and the 5 volts goes to 5 volts. And then the SDA, the serial data, goes to pin A4, and the SCL, the serial clock, goes to pin A5. If you don't want to remember those pins, on many Arduino boards there are also dedicated SDA and SCL pins. And with everything connected, let's jump back to the SimHub application. Here I will click the replay button to open the saved replays and play the last one. And since I have both displays connected at the same time, I can easily check if everything works fine. By the way, I'm using this tinted acrylic piece on the 7-segment display and a semi-translucent Windows sticker on the LED matrix display. This way it's a little bit easier to see those displays on camera. At this point we can remove the 7-segment display because we don't need it anymore, and then you can place the Pimoroni display anywhere you want. If you want to place it inside the shifter knob, then make sure to check my previous video. If you have any questions or comments, then put those inside the comment section. As usual, all the source files are on GitHub, the link is in the description. Thank you very much for watching and I hope to see you soon. Thanks and bye.